Alright, so today we are going to be going through 1-3, which is on vertex form and transformations. So we've got two learning targets here. We're going to find the vertex and the x-intercepts when it's in vertex form or in standard form, and then we're going to graph out transformations of a quadratic equation. So there's two forms of parabolas. One we've been covering already with standard form. That's the one you're familiar with, which is y equals x squared plus bx plus c. And then the one we're going to really focus in on today is vertex form, which is y equals a times, in parentheses, x minus h squared plus k. And when it's in that form, you can easily see the vertex because hk there is your vertex. So we're going to first look at some transformations here. We've got a basic parabola here. It's called a parent function, and it's y equals x squared, or f of x equals x squared. And we're going to go ahead now and just graph that out. So doing so, I'm just going to pick some nice x values here, like -2, -1, 0, 1, and 2. So then what I'm going to do here is I'm going to plug those x values in there and then be able to get my y value. So if I take -2 and I square it, I'm going to get a value there of 4. If I take -1 and square it, I get a value of 1. 0 squared is 0. 1 squared is 1. And 2 squared there is 4. So now we can just go ahead and graph those. So got 0, 0, I'm going to graph there first. And then -1, 1. There's it. And then we've got -2, 4. And then 1, 1. And then 2, 4. So then once I have my points on there, all right, I think I'm going to try that again. So I'm just going to regraph this. That was a mess. So let's see if I can do this. All right, a little bit better. So there's my parabola there. It's sitting there at 0, 0. So now that I have my graph there, my parent function there graphed, we can kind of compare these. So I'm going to go ahead and I'm going to bring up my graphing calculator here. And I'm going to graph, I'm going to go to my y equals here, and I'm going to plug in y equals x squared, that being my parent graph there. I'm going to hit enter there, and I'm going to plug in my new one here, which is x minus 3 squared. So let's plug that one in. X minus 3 squared, and we're going to graph those out and compare it. Now your graphing calculator is going to graph out the parent function there first, and then that x minus 3 in parentheses squared next. So you want to kind of compare them. So we've got this very first one there, and hopefully you can see where I always look at the vertex. So the vertex of the first one there is sitting there at 0, 0. The vertex of the second graph is sitting over there at 3, 0. So what happened? It shifted that graph over 3 to the right. So that's what I'm going to say here. Shift 3 to the right. So now that I've got it shifted 3 units to the right there, I could also just kind of graph these two back out here again. So if I want 0, 0, 1, 1, 2, 4 to kind of show you, -1, 1, -2, 4. So each one of those dots there, what I'm going to do here is I'm going to shift each one of those to the right 3. So if I count over from the vertex, 1, 2, 3, Now it's sitting there at 3, 0. If I take that 1 there, that 1 and 1, and shift it over 3, 1, 2, 3, to the right. Now it's sitting over there at 4, 1. If that negative 1, 1 is there, shift it over 4, 1, 2, 3. Shift it over 3. So now it's sitting over there at 2, 1. And I can do that for every single one of my red points there. I did for the original parent function. And then once I've done that, I can connect my points. I'm not doing a very good job of getting that very nicely. So again, you can do that every single time, or I'm going to show you another way of being able to do this as well, which just kind of depends on how you like to do these. So this one here, inside the last one there, you had a -3. This one's +4. So if -3 there, when you had an x minus 3 squared, it shifted to 3 to the right. Kind of thinking through that, what do you think would happen with the one here if it was not x minus 3 squared, but if it ended up being x plus, oops, delete that out of there. So I'm going to redo that. So punching that function in there, we've got x plus 4 squared. So graphing that one out, there's the original one, and this time when it was x plus 4, it moved it 4 to the left. So thinking about that, if you always have in mind that other graph there, what the ordered pairs there are, it was 0, 0, negative 1, 1. So 0, 0, if I move it 4 to the left, 1, 2, 3, 4. So it's sitting over there at negative 4, 0 now. And then from that, using the other ordered pairs that we've had from the parent graph, from that red dot there that I have on there, I can move 1 to the right and 1 up. I can move from the original red dot there, 2 to the right and 4 up. And then from that original red dot, 1 to the left and 1 up. And from the original red dot there, 2 to the left and 4 up. So you can also kind of always think about those nice ordered pairs there to kind of transform them. So that's kind of using transformations there and shifting it over. All right, so, and then I'm also going to indicate here, this is left 4 from the original, from the parent function. So if in the inside it moves it left and right, on the outside there where you don't have any parentheses there, think about what it's going to do with those. And those of you who had trig before, you might even have some other ideas there. So we could look at this one, so x squared here, and let's do the -2 here one. What happens with that when we graph it out? There's the original one, and there's that one. Notice it moved it 2 down. So if on the outside there, it -2 there moved it 2 down, well, on the outside there, when you got a plus, it's going to move it up 2. So again, when I do this, I think, okay, from 0, 0, I shifted it down 2, starting there with the vertex, and then from that point, I go 1 over 1 up, and then 2 over 4 up. And then I do the same thing the other direction, 1 over 1 up, from the original dot there, and then 2 over 1, 2, 3, 4 up. And then when I have those, it's so hard on this tablet to do that, but there it is. Not very good, but it'll work. So now coming down here and looking at the other one here, again, from the 0, 0, we're going to shift it up 2. So 1, 2. And then from that point, I can go 1 over 1 up, kind of like 1, 1. And then from the original point, I can go 2 over 4 up. From the original point, I can go 1 to the left and 1 up. And from the original point, I can go 2 over 4 up. It's kind of the way I like to do those. And again, I'm getting those values from the original one. You had -2, 4. We had -1, 1. We had 0, 0. We had 1, 1. And we had 2, 4. That was the parent function. So from that point, that's when I move in each time and graphing the additional pairs. So now let's change it up. So what happens if it's not being subtracted or added inside the x squared or on the outside being added or subtracted? What happens if we've got some multiplication going on? That's going to change your y values. So again, kind of bear in mind, this is your parent function, -2, 4, -1, 1, 0, 0. We had 1, 1, and we had 2, 4. What happens with one like this, it's like you're going to multiply your y values there by 2. So we call this one here a vertical stretch factor of 2. So you can think about multiplying your y values over here by 2. It's not going to move it. It's just going to stretch it out. So if I plot this, starting here at 0, it's still going to be 0, 0. And instead of being -1, 1, now it's going to be -1, 2 because you're multiplying your y values there by 2. Instead of being -2, 4, now it's going to be -2, 8. Instead of being 1, 1, it's going to be 1, 2. Instead of being 2, 4, it's going to be 2, 8. And then once we have that, we can connect those. So there it is. And then if you kind of think about the same one down here, you're going to multiply your y values down here by half. Now instead of stretching it, it's actually going to kind of shrink it. But it's up to you if you want to call it a stretch or a shrink. I like to call it a shrink. So I'm going to say by a factor of 1/2. All right, so coming over here, 0, 0. And instead of being 1, 1, it's now going to be 1 and then up a half. Instead of being 2, 4, now it's going to be 2, 2 because I'm multiplying my y values there by a half, my original y values from the parent function. Instead of being -1, 1, now it's going to be -1 1/2. Instead of being -2, 4, it's going to be -2, 2. And then I'm going to connect my points. So it's not getting closer to the y-axis, it's getting away from it. So that is our those types. Now we wanted to add one more where you got a negative on the outside. If you remember what the negative does, it flips it upside down. So we've got two things going on here. We've got a vertical stretch by 2, and we've got a reflection over x-axis. So what does that mean? Again, we're not going to change where we're at. It's still going to be there at 0, 0, but it's going to be upside down. And instead of being 1, 1, now it's going to be 1, -1 normally, but it's got that 2 there, so we're going to multiply it by 2, so 1, -2. Instead of being 2, 4, now it's going to be 2, -4, but we're going to multiply -4 there by 2, so we get 2, -8. Instead of being negative 1, 1, now it's going to be negative 1, but then multiply that by 2, and we're actually at negative 1, negative 2. Instead of being negative 2, 4, now we're going to be negative 2, 8. So then we want to connect those points. Oops. So there we have the graph of our parabolas using transformations. So I've got a couple here for you to try, so I'm going to give you a minute to try those out. So if you want to stop the video, this would be a good place to do that at.